What we have here is a pulley problem. We've got two boxes attached to each other through a rope around this pulley. So I want to find out a couple of things. One is, what is the acceleration of the system? And what is the tension in the rope that's connecting these two boxes? So what I got to do is I'm going to draw a free body diagram of each of the boxes, and then I'm going to link them together and find an equation that governs both and solve for the acceleration. Then it'll be easy to plug in and find the tension. So the first thing I got to do is draw the free body diagram for the 6 kilograms. I'm going to draw that here. Here's the 6 kilograms. And, well, if you look through the video about free body diagrams, you know the questions we're going to ask. Is there gravity? Yes, there's force of gravity on the 6 kilograms. Is it sitting on a surface? Yes, it is. So there's a normal force. Is there something pulling on it? Yes. There's tension pulling on it this way. That's what's going to make it accelerate to the right. Is there friction? Yes, and I've got the coefficient of friction here. So I know there's friction, and I'm assuming, I guess, that it's going to go accelerate this way, because this block is pulling down, and it's going to pull this block this way. Okay, so there's friction. The friction would be this way. And if I look at it, there looks like there's more force to the right than the left, and it's going to accelerate, so I'm going to say to the right is positive in this diagram. Let's look at the other one. We're going to draw the 5 kilogram box. I draw it over here. Is there gravity? Yes, there is. Is it sitting on a surface? No, it's not sitting on a surface. It's being held up by this rope. Is there friction? Well, it's not touching the side or anything, so there can be no friction. Is there something pushing or pulling on it? Yes, there's a rope here, and that is our tension. Is it accelerating? Yes, we're assuming it's going to accelerate like this, so this thing is accelerating down, so in this case, the acceleration down is positive. And one of the things I need to recognize is that the tension in this rope is constant. Even though there's a pulley there changing the direction of the tension will remain the same. So this number and this number are going to be the same. That's going to help us solve this problem. Okay, in order to solve for it, I've got to have an equation. So I'm going to find the equation in the x direction for this one. In the x direction, I've got tension forward minus friction, which is backwards, and that equals MA. So tension minus friction equals MA. I'm going to solve for the y direction because we usually solve for the y direction. It usually comes in handy, and I already know, since I've got this mu here, I'm going to need Fn for this box. So I might as well set down the equation for Fn here. So in the y direction, we say that I can choose up or down as positive. I'm going to choose up as positive. Fn minus Fg, and that's this g here for the 6 kilograms. So I'll put a little 6 there, and force of gravity for the 5, I'll put a little 5 there. Fn minus Fg for the 6 equals, and in this case, it's accelerating this way. So up and down, there is no acceleration. So this and this are going to add up to 0. So if I ever need Fn, I've got the information to get it. So let's look at our x direction. Force of tension minus force of friction equals MA. I need to get a number in here for the friction. So I have to solve for friction, and I know that the force of friction equals mu Fn. So here's where I need my Fn. Fn minus, and this force of gravity is 6 times 9.8, and that equals 0. So Fn equals 58.8. 58.8 newtons. So I can plug that in here. Force of friction equals 0.15 times 58.8 equals 8.8 newtons. I now know that the friction on this is 8.8 newtons. So let me plug it in here. Force of tension minus 58.8 equals M times 8. This is as far as I can go with this, but this is the equation that governs the motion of this. I need the equation that governs the motion of this one, and then I'm going to do something to the two of them to solve for the tension or the acceleration. So let's get the equation for this one. In the direction of acceleration, which is this way, the equation is going to be Fg, the force of gravity in the 5 kilograms, minus Ft equals Ma, 5A. I can solve for the force of gravity here. Force of gravity here is going to be 5 times 9.8, which is 49. This is the equation that governs this motion. This is the equation that governs this. I can put the two of them together and solve for the acceleration because the tension is going to drop out. Watch, it always happens. I've got here 49 minus force of tension equals 5A. And underneath it I'm going to put this equation, but I'm going to reverse this so that FTs are aligned together. So I'm going to have negative 58.8 plus Ft equals 6A. And now what I do is I just add the two equations together. This is going to be 11A. This is going to be the negative Ft and positive T are going to get rid of the Ft's. 58.8 minus 49 is 40.2. So I can solve for A. A is going to be 40.2 divided by 11 equals 3.6 meters per second squared. I'm sort of off the board, but it's 3.6 meters per second squared. Now I've got the acceleration of this system. I want to find the tension. That's going to be easy to do because I can plug either into here or into here. So what you're going to do is you plug in, if I take this one, Ft minus 58.8 equals 6, and my A was 3.6. You can solve for the tension, and it will be in Newtons.